Hi designers, welcome to SolidWorks Central. In this tutorial, we'll create a realistic shutter mechanism design. We'll model the shutter blade, upper ring plate, lower ring plate, and pin parts, and then assemble them to form a complete shutter mechanism. Throughout this project, we'll use commands such as extruded boss base, circular pattern, chamfer, extruded cut, axis, mates, and circular component pattern to build the mechanism step by step. Then, we'll apply appearance and color adjustments, and finally bring our design to life with a scene setup and motion study. Let's dive in. First, open a sketch on the front plane. Select the Circle tool. Draw a circle centered at the origin. Set this circle for construction to make it a reference. At the top point of this reference circle, draw another circle. Now, I'd like to briefly explain something important that will make your workflow faster. In SolidWorks, there are three main ways to access commands and tools. First, you can select your commands directly from the tabs at the top. Second, you can press the S key on your keyboard to open the shortcut toolbar. And third, by holding the right mouse button and moving slightly, you'll open a quick radial menu to access your favorite tools. Throughout this tutorial, I'll use the top tabs so you can clearly follow each step. But feel free to use shortcuts, whichever feels most comfortable for you. If you'd like to learn how to customize or edit these shortcuts, let me know in the comments below. I can make a short tutorial just for that. Let's continue. Select the Smart Dimension tool. This circle's diameter is 100 millimeters. The reference circle's diameter is 85 millimeters. This circle's diameter is 8 millimeters. And the smaller circle's diameter is 4 millimeters. Now, let's thicken the dimension font and hide the extra digits after the decimal point. Open the Options panel. Click OK to confirm. Now, select the Centerline tool. Draw a vertical centerline starting from the origin. Activate the Line tool. Draw a line from the origin, angled upward. Double-click to finish the line. Do the same on the other side. Now, add a symmetric relation. While holding Ctrl or Shift, select these three lines. Apply the Make Symmetric relation. Activate the Smart Dimension tool. Select the two angled lines. Set the angle between them to 30 degrees. Shaded Sketch Contours shows closed sketch areas in colour. This helps you easily see which regions are fully closed. If it's turned off, closed areas will appear without colour. Activate the Trim Entities tool. Make sure Power Trim is selected. Select the Centerline tool. Draw a horizontal centerline from the origin. Now, select the Circle tool. From this point, draw a circle. Activate the Smart Dimension tool. This centerline length is 35 millimeters. This diameter is 120 millimeters. Activate the Trim Entities tool. Trim the excess lines. As we can see, our sketch is fully defined and there are no open areas. Everything is closed. Now, Apply fillet to the corners. Activate the Sketch Fillet tool. Set the fillet radius to 6 mm. Apply it to this corner and this corner. Right-click to confirm. Now we can give our sketch some depth. From the Features tab, activate the Extruded Boss Base command. In the selected Contours box, choose the closed area where you want to apply the depth. Keep the end condition set to blind. Set the depth value to 2 mm. Click OK to confirm. Open a sketch on the back face of the part. Now, select the Straight Slot tool. Draw the slot horizontally. Activate the Smart Dimension tool. This slot's radius is 0.5 mm. The distance between the slot center and the origin point is 38 mm. The slot length is 14 mm. The slot is not fixed yet. It can still move side to side. While holding Ctrl or Shift, select the slot center, then the origin point, and apply a Make Vertical relation. The slot is now fully defined. Activate the Extruded Boss Base command. Keep the end conditions set to blind. Set the depth to 1 mm. Make sure Merge Result is active. Click OK to confirm. The shutter blades part is now complete. Let's quickly add an appearance and colour. Now, let's save this part. Create a separate folder for all your parts. Save this file as shutter blades inside that folder. You can now close this part. Press Ctrl+N to open the new document window. We'll continue with the Part option. Click OK to open it. Or you can double-click on the Part option to start modelling directly. Open a sketch on the front plane. Select the Circle tool. Draw the circles centred at the origin. First circle. Second circle. Third circle. Set this one for construction. Fourth circle. Also set this one for construction. Now, activate the Smart Dimension tool. This circle's diameter is 122 mm. This circle's diameter is 72 mm. This construction circle's diameter is 85 mm. Finally, this construction circle's diameter is 111 mm. Select the Centerline tool and draw a vertical line from the origin. You can turn off shaded sketch contours. Select the 3-point arc slot tool. Select this intersection point and then this construction circle. Create an arc slot between these two construction circles. Activate the Smart Dimension tool. The arc radius is 50 mm. Set the slot radius to 2 mm. select the Centerline tool. From this intersection point, draw an angled centerline. Add a tangent relation between this centerline and the slot's arc centerline. Activate the Smart Dimension tool again. The angle between the angled centerline and the vertical line is 60 degrees. The sketch is now fully defined. Now, give it some depth. Activate the Extruded Boss Base command. Keep the end condition set to blind. Set the depth value to 2 mm. Click OK to confirm. Now, create a circular pattern for the slot. Activate the Circular Pattern command. For the pattern axis, select the rotation center. You can select the circular edge or the circular face, since both share the same center axis. Make sure equal spacing is checked. Set the total angle to 360 degrees. Set the number of instances to 12. In the Faces to Pattern box, click to activate it. Right-click on any face of the slot. Choose Select Tangency. This will automatically select all 4 faces of the slot. Click OK to confirm. Now, activate the chamfer command. Keep the angle distance type selected. Set the distance value to 0.3 mm. Apply the chamfer to both the outer circular and inner circular surfaces of the part. Click OK to confirm. Quickly add an appearance and colour. You can choose any appearance and colour you like. And finally, save this part. Save it as upper ring plate, then close this part. Open a sketch on the front plane. Select the Circle tool. Draw 2 circles centered at the origin. Activate the Smart Dimension tool. This circle's diameter is 122 mm, and this circle's diameter is 72 mm. Activate the Extruded Boss Base command. Keep the end condition set to blind. Set the depth to 2 mm. Click OK to confirm. Open a sketch on the front face of the part. Select the Circle tool. Draw a circle from the center and set it. For construction, activate the Smart Dimension tool. Set the diameter to 76 mm. Select the Straight Slot tool. Draw it horizontally. Activate the Smart Dimension tool. While holding Shift, select the origin point. Then, select this point. Set the horizontal distance between them to 7 mm. The slot length is 50 mm. The slot radius is 0.5 mm. Select the slot center line, then the construction circle, and apply Make Tangent. The sketch is now fully defined. Now make the cut. Activate the Extruded Cut command. Set the cut depth to 1 mm. Click OK. Create a circular pattern for this cut. Activate the Circular Pattern command. For the pattern axis, select the circular edge. Keep the same settings as before. In Features to Pattern, select Cut Extrude, 1 from the tree. Click OK. Activate the chamfer command. Set distance to 0.4 mm and apply it to the outer circular and inner circular surfaces. Quickly add an appearance and colour. Save this part as well. Save it as lower ring plate, then close the part. Open a sketch on the front plane. Select the Circle tool. Draw a circle centered at the origin. Activate the Smart Dimension tool. Set the diameter to 4 mm. Activate the Extruded Boss Base command. Keep the end conditions set to blind. Set the depth to 4 mm. Click OK to confirm. Activate the chamfer command. Set the distance to 0.25 mm. Select the cylindrical surface. Click OK to confirm. Apply an appearance and colour to finish the look. We've now created our final part, a simple pin. Save the file. Save it as pins and close the part. Open an assembly document. Insert the lower ring plate as the first component. The first inserted part is always fixed in place. Try to move it. You'll notice it doesn't move. In the feature tree, you'll see an F symbol next to its name, meaning fixed. Right-click the part and choose Float. Now the part can move freely. The assembly origin and the part origin are currently not aligned. Create an axis at the real origin. Under Reference Geometry, select the Axis tool. From the feature tree, select the front plane, then the origin. This will create an axis that passes through the origin and the front plane. Click OK to confirm. You can make the axis visible if needed. Activate the Mate command. Add a coincident mate between the front plane and the back face of the part. Select the axis and the circular surface to add a concentric mate. Go to Insert Components and open the next part. Insert the shutter blades part. Select the front face of the lower ring plate, then the back face of the shutter blades, and add a coincident mate. Select this face, then this face, and add a coincident mate. Without exiting the mate command, select the right plane, then this face, and add a parallel mate. Now, insert a new component. Insert the upper ring plate part, select the circular faces of both rings and add a concentric mate. Move the upper ring plate slightly forward. Select the back face of the upper ring plate, then the front face of the shutter blades, and add a coincident mate. Insert the pin part. Select the cylindrical face of the pin, then the inner face of the shutter blade hole, and add a concentric mate. Select this face, then this face, and add a coincident mate. Select the cylindrical face of the pin, then the slot face, and add a tangent mate. Now, apply a limited angle to the upper ring plate so it moves together with the pin within specific ranges. Activate the Mate command. Open the Advanced tab. Expand the feature tree. Open the upper ring plate and select its top plane. Now select the main top plane. Enable the Angle Mate option. Set the maximum value to 70 degrees. Also set the angle value to 70 degrees. As we can see, that angle looks a bit too large. Adjust the value until it fits perfectly. Set the angle to 52.60 degrees. Set the maximum value to match this angle. Set the minimum value to 0 degrees. Click OK to confirm. The maximum value looks fine, but we need to reduce the minimum angle. From the Mates section, click on the Limit Mate and select Edit feature. Set the minimum value to -15 degrees. Set the shutter blade and upper ring plate to transparency mode. This will make the movement easier to see. You can now turn off the transparency for both parts. Now, create a circular pattern for the shutter blade and pin. Activate the Circular Component Pattern command. For the pattern axis, select the cylindrical face again. In the Components to Pattern box, select both the shutter blade and pin. Set the number of instances to 12. Keep the other settings as they are. Click OK. And now, the mechanism moves exactly as we wanted. Now, set up the scene and then move on to the motion study. Switch to the Motion Study tab. If the Motion Study tab is not visible, right-click on this area, go to Toolbars and enable Motion Manager. Move the timeline slider to the 4-second mark. We'll make this motion complete by the 4-second mark. Now, move the timeline slider to the 8-second mark and let the next motion complete by the 8-second mark. Add a 1-second pause at the end of the timeline. Now, click Calculate. The Calculate button processes the motion and generates the animation preview. Save the animation. The file name can stay as ASIM1, or you can change it if you want. Change the file type to MP4. Adjust the frame size as you prefer. Set the frames per second to 100, or use a lower value if you prefer. Click Save. Choose No when asked to recalculate. We don't need to calculate again. Frames per second defines how many images are shown per second of animation. And that's how we've completed our realistic shutter mechanism model in SolidWorks. If you found this tutorial helpful, don't forget to like the video, subscribe, and turn on notifications for more step-by-step SolidWorks lessons. You can also join the channel to support my work and access all model PDF drawings. Thanks for watching, and see you in the next video.